Hello. I prepared a new device. It is a tablet. So let me try if it works. How it works. So today we are going to do homework homework 2. Yeah, it works. It works more than I expected. Better than I expected. It's good. By the way, I'm still very slow to do this. Sorry about that. So in homework 2, like say question 1. Question 1. We know that it is a Cobb-Douglas production function, alpha 0 plus beta 0 Li plus gamma 0 Ki plus epsilon I, but we do not observe this K, therefore we can rewrite instead of observing K itself, we add and subtract Ui, and this much is the observed proxy variable for the capital, like something something measured from the accounting, and this much is together the unobserved error term. So we have Hi plus epsilon tilde I. Therefore, it is easy to show that they are correlated. So covariance between Hi and epsilon I tilde can be calculated. Covariance Ki plus Ui, minus gamma 0 Ui plus epsilon I. And by the assumptions, K is independent. K is uncorrelated with U. K is uncorrelated with epsilon, and U is uncorrelated with epsilon. So the only correlation we can capture is U, U, but it equals to minus gamma 0 variance of U. So as long as gamma is not 0 and variance is not 0, the correlation is not 0. So it's obvious. Most of you have done pretty well. And so the second, can I? Can I? Oh no. No. I don't know. Oh no. So I don't know how to. How can I? Oh yeah. Okay. Good. So then B, we would like to derive the misspecification bias, and so here it becomes a little bit more complicated, and your answers start to look more ugly. And so many of you have tried this way. It is not wrong. So 1 K like L and H. So basically you are regressing Y, the output on constant, intercept, and labor, and a proxy of the capital. So let me try to erase it. So where is it? It doesn't work. Oops. Let me use eraser. Okay. So I'm interested more in practicing this tablet than teaching you. So if you use this, then you may want to show that then you and say theta is alpha, beta, gamma. So if you put it this way, theta hat will be estimated as xi prime inverse xi yi. And we would like to show that, expected value. I forgot expectation. It's fun to use this. So then, so this part is easy. What you have to do here is expectation xi, and y can be written as xi prime theta plus epsilon tilde. So therefore, you can have theta 0 plus expectation xi prime inverse expectation xi epsilon I tilde. And so this is not a problem again. So it's a 3 by 1 vector, expectation of 1 times epsilon I tilde, and expectation of labor and epsilon, and expectation of h and epsilon I tilde. And we know that epsilon consists, epsilon is, epsilon, no. How can it go? Epsilon is defined in this u and epsilon. So epsilon tilde equals to minus gamma u plus epsilon. Therefore, where is the cursor? Okay, where is the cursor? It equals to 0. The first guy equals 0, and the second guy also equals to 0, because the labor is uncorrelated with epsilon by the assumption, and the u, the measurement error, is also uncorrelated with any variable in the let me see. So did I yeah, okay, but this guy has a problem. As you can see, the last guy has a problem, variance of u. So this is not 0. The last one is the source of the misspecification bias. This part is easy, but many of you have trouble in here. It is a 3 by 3 matrix. Then how can you get the inverse? So it is possible. Maybe you can do it by hand. 3 by 3 is not impossible, but that is not a good idea. So it is the method 1 does not work. The method 1 is correct but difficult. So here, of course, the best way is to demeaning the variable. So suddenly, in the previous homework, many of you have used the demeaning technique whenever, like, even if it is not required. But in this homework, many of you did not use demeaning at all. So you have to utilize what you learned. So demean the variables. And so, for example, if xi is li bar or h bar, suppose that li and hi are the demeaned variables, then simply you can use beta and gamma. Oh, what is it? Beta and gamma. So the intercept will disappear, and here then in this case theta will be expected value of, again, xi prime. Now remember, xi is defined as 2 by 1 vector. It is different from what we did yi bar. Now you have to demean y bar. So let's put it as x bar, just to show that everything is demeaned. And then so here x bar. So this part has no problem again. It is, in the end, it will be li bar epsilon I tilde and hi bar epsilon tilde. So anyhow, they are covariances. So you can calculate them, and then it is 0, and it is minus gamma variance u. So you know them. So this part is easy. So excuse me, it was not correct. So to be more correct, I had to write this way. Tilde plus theta. And theta is the correct theta hat. Here I had to start from theta hat. So this guy is well known. So now the misspecification bias depends only on this. And it is now 2 by 2 matrix. It is what 2 by 2 L bar squared, expectation L bar H bar, and expectation L bar H bar, and finally H bar squared. So the x prime x is this, and you put inverse of that, and this is the variance of L, this is the covariance, covariance, variance. So you may simply write it this way, say sigma L squared, sigma LH, sigma LH, sigma H squared. It does not matter, whatever you use. You may use a simple notation, and of course, you have to put inverse, and then you know how to calculate this. It is sigma L squared, sigma H squared minus 2, my sigma LH squared, yes, right, and H squared minus sigma LH minus sigma LH, sigma L squared. This is H, this is L. Anyhow, so now you can calculate the misspecification bias is this guy multiplied by 0 and minus gamma sigma u squared, variance of u. So you can calculate the result. So remember, it is not. So beta, so here it is. So the first, you are going to get two things, 2 by 1 vector, and the first one is bias in beta, and the second one is bias in gamma, right? So what you need to know here is the bias in beta is not 0. Even if the problem was coming from the capital, whose coefficient was gamma, obviously gamma must be biased, but beta is also biased as long as H and L is correlated. So this is best way to derive the final answer. We know there is a misspecification bias, but just to show that to show its closed form solution, then maybe by hand this is the best you can do. And then you may, so still I'm not ignoring alpha. At the end, a perfect answer would have alpha as this way. Expectation of, so alpha can be written as in this way. So beta expectation L minus gamma expectation of H. Of course, these guys are estimated guys. So in other words, this so you may write it this way: minus 2 by 1 matrix, 2 by 1 vector prime this bias, theta plus bias. So then, of course, if this guy, so this much will be the true alpha, and the bias is coming from so it is 2 by 1 and also 2 by 1. So prime after prime 1 by 2, 2 by 1. So it will be a scalar. So this is how you calculate the bias in alpha. And so this is the best way of complete answer. By the way, what I wanted to tell you here is that many of you have used this method, wrong approach. So many of you claim that gamma is covariance between y and h divided by variance of h. This is it is true when H is the only regressor, right? So you are ignoring, so compare that with this form. Oh, what is it? No. What happened? What happened? Undo? No. Oh, no. Something happened, which I don't know. Oh, here's cancellation. Cancel. All right. Okay. So if you compare with this, then you are ignoring this part. So if the covariance between L and H equals to 0, then you can say this. Then this is right. However, it is in general in this question, I did not assume the labor and capital are uncorrelated. Obviously, just economically, in capital and labor must be correlated, usually positively correlated. So in any sense, it's wrong. So this is wrong. Or if for at minimum, when you say this, you have to say that the computation is too hard. So I'm going to assume, I will assume like covariance between these two guys equals to 0. And so please give me some partial credit. Something like that. Otherwise, your approach is totally wrong. Right? Okay, this is question C. And part, what time is it? I will continue in the next one. I'm really enjoying this tablet.